Alright, how's it going, everybody? Welcome to my first video lecture and my attempt at flipping the classroom. I'm going to start by going over these practice problems that were handed out in class, so hopefully you guys have tried these and you can see how well you're doing. And also, I hope that you guys will use this as a review before our next Unit 2 test. I apologize in advance. I'm sick, so I might sound a little sniffly or I might be coughing through this, so again, I apologize, but let's just dive right into it. Okay, so number one here, Aunt Minnie gives you $10 per second for 4 seconds. How much money do you have after 4 seconds? So I got my highlighter out. I'm gonna highlight the important stuff. This one's pretty straightforward, so maybe you guys don't have to do this, but I'm just gonna cover my bases. Okay, so the important stuff is $10 per second times 4 seconds should give us, you see how the units cancel out, $40. Okay, hopefully that one all made sense to you guys. These first couple are pretty straightforward and you probably don't have to use much of your equations to solve them, but let's move on here. Okay, so you can see this one. A ball dropped from rest picks up speed at 10 meters per second after it falls for 4 seconds. How fast is it going? Okay, so again, let's highlight the important stuff. This one's not as intuitive, but from rest tells us important information. It tells us that the ball has an initial velocity of 0. Okay, so I can say that right here. V initial equals 0. Okay, and then it picks up speed at 10 meters per second. So we have to pay attention to these units here. These are actually telling us meters per second squared, which is our acceleration. Okay, it falls for 4 seconds, which is our time, and it wants to know how fast it's going. How fast indicates that it wants a velocity. Okay, so we could use our kinematic equations here, but you probably could intuitively solve this again the same exact way that we solved number 1, right? 10 meters per second squared times 4 seconds is 40 meters per second. Okay, so we can write that, we can write that over here in the provided space, 40 meters per second. Okay, I'm messing up. Okay, let's move on to number 3 here. Fill up the whole page. Okay, so you now have $20 and Uncle Harry gives you $10 each second for 3 seconds. These are some pretty good aunts and uncles you have here if they're just paying you per second. But let's go through the important information again. You start with $20. Uncle Harry gives you $10 each second for 3 seconds. How much money do you have after the 3 seconds? Okay, so again, excuse me, this one's the exact same as the first two, right? We have $10 per second times 3 seconds. Okay, our units cancel out again. Make sure we're keeping track of units. That's how we help us to solve these problems. Okay, so this is $30. But again, we have to be careful because over here it told us that we started with $20. So we need to make sure that we add that and account for that in the problem. So $20 plus $30 should give us $50. Okay, and then I'll continue over here and I'll write this right there, $50. Perfect. Okay, number 4. A ball is thrown straight down with an initial speed of 20 meters per second. After 3 seconds, how fast is it going? Okay, so again, important information. Thrown straight down with an initial speed of 20 meters per second. After 3 seconds, how fast? Okay, so this is telling us thrown straight down. Why did I highlight that? Well, that's important information because, as we should know from class lectures, direction is really important to take into account. So this thrown straight down means that this initial speed should actually be a negative 20 meters per second. So again, this one's fairly intuitive. We haven't gotten into any of the difficult ones, but this should be a negative 20 meters per second times 3 seconds. Okay. Our seconds cancel out. Hold up. We've done this wrong, and I know because, or I've done this wrong, excuse me. And I know because I checked my units, right? My units here are telling me that by doing this calculation, I'm left with meters, which isn't how fast, it's a distance. So that means that I've set something up wrong, right? So I give it an initial speed of 20 meters per second. After 3 seconds, how fast is it going? Well, let's see here. We can use our equations, and we have, let me look at them. What do we have? What do we know? We have time, we have initial velocity, and we know acceleration. Why do we know acceleration? Well, because it's thrown straight down, which indicates to me that gravity is working on it. So my acceleration, my pen's not working. My acceleration equals negative 9.8 meters per second squared. So if I look at our equations from the practice problems that we've been given or from our notes, we can see that there is an equation that uses all of these variables. Our V final is equal to our V initial plus acceleration times time. Okay, so now basically I just plug in my variables, right? My initial speed or my final velocity is equal to my initial speed, which is in the negative direction, negative 20 meters per second, plus my acceleration, which is negative 9.8 meters per second squared. I'm gonna have to slide over, times time, which was 3 seconds, I believe. Yep, 3 seconds. Okay, so 3 seconds. Okay, now we should check our units. Seconds cancels off here, and because this is seconds squared, the squared goes away. So I'm left with negative 20 meters per second and 9.8 meters per second times 3, which should be about 30. Okay, I'm going to check it on my calculator here. Times 3 gives me actually 29.4. We'll just call it 30 for right now. Whoops. Let me actually redo that. There we go. Negative 30 meters per second. Plus, we also have this negative 20 meters per second. So our V final should be negative 50 meters per second. Okay. Okay, so hopefully you guys all got that. And maybe if you were headed down the wrong path like I was, you were able to stop and turn around because you caught yourself with your units. Hopefully this is an indication of what you can do on a test to make sure that you're doing it right. Okay, so now we're going to move on to problem number 5. Okay, you have $50 and you pay Aunt Minnie $10 per second. When will you run out of money? Well, this one's pretty straightforward again. Okay, so I should have $50. Okay, and if I pay attention to my units, when I divide by $10 per second, it's the same as multiplying, right? When I pay attention to my units, in order to get these to cancel, I have to multiply them by the reciprocal, all that fancy math. Afterwards, I know my dollar signs cancel out, and I'm left with seconds, which is what I was looking for, right? I didn't highlight this information, but I'll go back and do that. $50, Aunt Minnie gives you $10 per second. When will we run out of money, right? So when will we? We're looking for time, and now my units show that I solve for time. This should be 5 seconds. Again, you guys probably figured these ones out intuitively without setting up your equations. That's 5 seconds. That's an S. We'll do S. EC seconds. Okay. Okay, here's where it gets a little bit trickier. So we gotta make sure we got our equations on hand. Excuse me. Okay, so we shoot an arrow straight up at 50 meters per second. When will it run out of speed? Okay, so I'm going to go and I'm going to look at my equations. Okay, and it looks like I have an equation, excuse me, that is acceleration equals delta V divided by delta T. Okay, and you might be thinking, wow, this doesn't look like anything that we need, but let's go through our information again. Okay, so shot an arrow straight up. Okay, that indicates that we're using gravity, right? Gravity's having an effect on it because it's in free fall. So that means my acceleration is equal to the gravitational force. Okay, and it's given an initial at 50 meters per second. When will it run out? Okay, so this delta V, remember this delta V means the change in velocity, which means my V final minus my V initial. Okay, and we're talking about when it runs out of speed, So that means that speed is 0. So my V final is 0. So I'm solving for time, right? Because it asks when will it. So let's rewrite this equation to begin with. So I should have delta T is equal to delta V over A. Okay, that's algebra. You can check that. You guys, once you run through that, that should check out. Okay. Whoops. So my delta V is equal to my V final minus my V initial. Well, my V final is 0 meters per second. My V initial is straight up at 50, okay? But because it's minus, right, in the equation, V final minus V initial, we have that minus a positive 50 meters per second, okay? If the arrow was thrown straight down or shot straight down, remember this 50 would be a negative, so this minus a negative would have flipped to a positive. So signs are super important, okay? So minus 50 divided by negative 9.8 meters per second squared. Okay, when I run through this algebra, all these are going to cancel out. Meters, seconds. And the second squared canceled out, but it leaves me with 1 second, or just a second unit. Okay, so again, we were solving for time, and our units show that we solve for time by leaving the units of time, which is seconds. And when I run through this, I should get about 5 5 seconds, right? Another 5 seconds. And this is important again too, because if you would have left off this negative for gravity, or added a negative weird on the 50, or maybe you added them instead of subtracting your V final and your V initial, you would have gotten negative 5 seconds. And can we get negative time? Sadly not, right? Time is linear and it only moves forward. We can't go back. So if you got a negative time, that's your indication that, hey, something went wrong. All right. Moving on, number 7. So what will the arrow speed 5 seconds after you shoot it? What will the speed be 5 seconds? Okay. So again, I can use that same formula, but I can rewrite it again to solve for my V final, right? So, whoops, I gotta stop doing that. So this equation was acceleration equals V final minus V initial divided by delta t. Okay. So if I solve this, excuse me, I thought I was going to sneeze. If I resolve this for V final, I should get V final is equal to V initial plus acceleration times time. Right? That delta goes away because we assume time started at 0. And this looks a whole lot like this equation, right? Okay, so now you've seen the derivation of how that equation was actually solved. Yeah. So now I basically just plug in what I've been given, right? So again, this was using the same values from problem 6. So my V initial, we'll solve like this. V final equals my V initial, which was negative 50. No, positive 50. 50 meters per second plus negative 9.8. I'm writing right in this next problem's answer slot. Oh well. 9.8 meters per second squared. And we want to know where it'll be after 5 seconds, right? 5 seconds, okay? So it will be at about, once we calculate this, it'll be at, or its speed, its speed will be at about 1 meter per second. Okay, hopefully you've done that on your calculator and that checks out. I'm going to try to speed this up so it doesn't take half an hour trying to run through this practice problems. Okay, so going to the next one. Same thing, what will the speed be 6 seconds after we shoot it? Okay, so now we're just redoing these equations. My V final is my V initial, still using the problem, or the question number 6 units values, we'll call it 50 meters per second plus negative 9.8 meters per second squared times 6 seconds. Okay, and now we should get 9.8 times 6 negative equals negative 8.8. Okay, hopefully that's right. Let me double check that. Looks right. Okay, and that's meters per second. So that was the answer for number 7. And now, or I guess that was the answer for number 8, part 1. And then there's this second part, which is asking for it after 7 seconds. So we'll do that again. V final is 50 meters per second plus negative 9.8 meters per second squared times 7 seconds is 9.8 times 7 seconds minus 50 negative 18.6 meters per second. Okay. Let me double check these answers. Yeah, they look right. Okay. So why are these negative? Let's talk about that real quick. Okay. So hopefully you were in class and we talked about this in class, why they were negative. Negative signs, remember, signs on our units or our values indicate direction. So these tell me that at 5 seconds, this arrow reached its peak, right? It slowed down to almost 1 second, and we know exactly at 5 seconds that the arrow slowed down to 0. It ran out of speed, right? That's what it was asking us. Okay, so that means when I throw something up, it hits a peak at some point where it runs out, gravity is too strong on it, and it starts returning back to Earth. Okay, so at these points, it was speeding back up down to Earth, right? Because of the acceleration due to gravity, it peaked, it reached its peak, and then it changed direction, started coming back down to Earth, and that's why it's negative. Okay? So again, when you're running through these problems, you need to make sure that they're making sense. And you need to be able to answer the question, why is it negative? All right? And if it is negative, why does it make sense that it's negative? Okay? So don't get a negative and start freaking out on your test or whatever. Okay. So now we are onto the free fall distance part. Okay. Speed is one thing, distance is another. How high is the arrow when you shoot up at 50 meters per second when it runs out of speed? Okay. So let's highlight what is important here. How high? That's distance in the y, right? Up and down. When we shoot an arrow at 50 meters per second, that's a velocity. Okay. I'm assuming it's an initial based off this next part when it runs out of speed, right? Because when it runs out of speed, that's its final velocity. So I know, or I'm looking for distance. I know my initial velocity, I know my final velocity, and I also know my acceleration, right? Because this is in free fall. All these problems are telling me free fall. Okay, so that means it's subjected to acceleration as gravity. So now I need to look through my equations. Which equation should I use? Probably this one, right? D equals VIT plus 1/2 AT. That's an A. I don't know why these A's aren't really registering with my stylus. Okay. So let me make this bigger so I can write more clear. So hopefully you got that equation. I'm going to erase it real quick. And I'll write it right here. D equals VI times T plus 1/2 AT squared, right? Squared. Don't forget that square. It's super important. And it'll throw your answer off by, exponentially. Okay. So I'll rewrite down here. Distance equals, what's my initial velocity? Well, my initial velocity is I shot straight up at 50 meters per second. That's my initial velocity. So it's a positive 50 meters per second. Times time, right? Well, we don't know time. Oh, I guess what this problem is basing it off of is it's still basing it off of problem number 6, right? So we know it runs out of speed after 5 seconds, right? We solved that for number 6. So I'm just going to use that down here. And I know that is probably confusing for a lot of you. On the test, we'll make sure that it's very clear which numbers you're supposed to be using. Okay. Plus 1/2. Acceleration is negative 9.8 meters per second squared times 5 seconds. Okay, so we get out our calculators. Whoops, did I say 6 seconds over here? This is supposed to be 5 seconds. Okay, 5 seconds. Correct? Yeah. Okay. So 9.8 times 5 seconds divided by 2. Okay, divided by 2 plus 250, right? So I got hold up. I messed up. You see where I messed up? Hopefully you guys saw it. Hopefully you saw it. Squared. Okay? I need to make sure I square that. 5 squared is 25 times 9.8. There we go. This is making more sense. Okay. So, I got 127 meters. Okay, hopefully you guys got similar answers to that. Okay, and now it wants to know how high it will be 7 seconds after being shot. Okay, so again, we'll go through these. Whoops, draw, highlight. How high? 7 seconds, 50 meters per second. So it's asking the same thing. Okay, let me zoom in again. Distance equals 50 meters per second times 7 seconds now, plus 1/2 negative 9.8 meters per second squared times 7 seconds squared. Okay, we need to make sure. And again, see how I caught myself last time as I checked my units. Okay, so seconds squared cancels with seconds squared. Seconds cancels with seconds. So I'm left with meters plus meters. And I'm looking for how high. Okay, I'm looking for distance. So this makes sense. This is how I check myself. So make sure you're running through this on a test or whenever you're practicing these. Okay, I will use my calculator now. 7 squared is 49 times 9.8 divided by 2. Okay, and then 50 times 7 is 350. So you should get about 100. Oh, I'm still in red. 110 meters, or specifically 109.9. Right? Okay. All right, we got about 4 more. So hopefully I haven't taken too long. I'm not really sure. I've been looking at the clock, but we'll just run through these last ones. Okay. Aunt Minnie drops a penny into a wishing well and it falls for 3 seconds before hitting the water. How fast is it going when it hits? All right. So let's look at our equations. Which one looks good? I think I found one. Let's go through this real quick though. All right, what do we know? She drops it, right? Drops a penny. What does that indicate? Well, to me, when you drop something, you're not throwing it downwards. You're not giving it an initial velocity. So to me, that means an initial velocity should be 0. Okay? It falls for 3 seconds. That's time, right? 3 seconds is time. So we have VI and we have time. We want to know how fast. That's V final. Okay? And she dropped it into a wishing well. That means it's in free fall, so I know my acceleration is equal to gravity. So now I know which equation I'm using, right? And we all should know what equation I'm using. Hopefully you already know. If you don't, it's V final is equal to V initial plus acceleration times time. Okay. Again, my V final is dropped, or my V initial was dropped, so that should just go to 0. So my V final should be my acceleration times my time. So it should just be V final equals negative 9.8 meters per second squared times 3 seconds. Right? If I check my units, seconds cancels out with the seconds squared. So I'm left with meters per second, which is a velocity or a speed. Okay? So this should be about, using my calculator, I get 29.4 meters per second. Okay? You probably noticed I did something wrong. Forgot my direction, right? Negative 29.4 meters per second because it's going downward. It's falling. Okay, hopefully you guys caught that before I said something. Okay, part B. What is a penny's average speed during the 3-second drop? Well, to average, I need my V initial, right? This should be in your equations. V average should equal my V initial plus my V final divided by 2. So this is 0 seconds, or 0 meters per second, excuse me, plus that negative 29.4 meters per second, negative 20, I'm running out of space, negative 29.4 meters per second. Okay, divided by 2, that gives me about negative 14.7 meters per second. Perfect. All right, part C, how far down is the water? Okay, so I still know my V initial, my V final, my acceleration, okay, my time. I'm looking for how far, that's distance. Okay, so let's look at one of those distance equations. Okay, so I have D equals VIT plus 1/2 AT squared, but I know my V initial is 0, so that part should just cancel out, which leaves me with D equals 1/2 acceleration times time squared. Don't forget that square, okay? So we know 3 seconds. Okay, so I'll rewrite this. 1/2 times negative 9.8 meters per second squared times 3 seconds squared. I don't have enough space on this worksheet. Okay. And that is 3 squared, which is 9, times 9.8. Okay, that's about 90. Let me do it on my calculator. You'll get, what, 88.2 divided by 2 gives me 44.1. Okay, 44.1 meters. And again, it's downward, so that has to be negative. Okay. Hopefully this has all made sense because we're on the last one, and hopefully it's all come to this and you should be able to solve this. If you'd like to, pause the video and solve it on your own. If not, I'm going to continue on. Okay, Aunt Minnie didn't get her wish, so she goes to a deeper wishing well and throws a penny straight down into it at 10 meters per second. How far does the penny go in 3 seconds? So again, this is the same problem, but now she's thrown it straight down. She throws it straight down. So she didn't drop it anymore. She's getting angry, and she decided to throw it. Okay, so I'm going to use this blank area down here. So now I'm using the same equation, but I'm not dropping my V initial because she's given an initial velocity, right? She's thrown it. So I need to include that. T squared. Okay, so using the information, okay, D is equal to my initial velocity is 10 meters per second, right? And it should be what? Negative, right? Because it's straight down. Negative 10 meters per second times how many seconds? 3 seconds times 3 seconds plus 1/2 times negative 9.8 meters per second squared times 3 seconds squared. Okay, so let's do this on the calculator. 3 squared is 9 times 9.8 is 88.2, and half is negative 44.1, right? Okay, and then we have plus negative 30, right? So I should get negative 74.1 meters. Alright, so this is my first video lecture. Hopefully you guys followed along. Hopefully this helped you learn, okay, and hopefully helped you review for the test or whatever the case may be. I hope it helped, and I hope moving forward this is something that we can all get on board with and enjoy and use to further our knowledge in physics. Thanks for your time, thanks for listening, and I'll see you in the next video.